Welcome to Word of Mathematics and Spherics with me, Irina Petrova. The author of the first work on spherics was the mathematician and astronomer Eudoxus of Cnidus. But the most important work was the Spherica. By Menelaus of Alexandria, a Greek scholar who lived in the 1st century, spherical geometry wasn't just for astronomers, navigators of naval ships, airplanes, spacecraft, who used the stars to determine their coordinates, but also for building mines, subways, tunnels, as well as in geodetic surveys of large areas territories of the Earth's surface when it becomes necessary to take into account its sphericity. First, let's define a few terms. A sphere is the set of points which are all within the same distance from a given point in space. Radius of the sphere is the distance from the center of the sphere to any point on its surface is called the radius. A spherical triangle is a figure formed on the surface of a sphere by 3 great circular arcs, intersecting pairwise in 3 vertices. The spherical triangle is the spherical analog of the planar triangle, and is sometimes called an Euler triangle. There are no similar triangles on the sphere. Unlike in planimetry, the sum of the angles of any spherical triangle is greater than 180 degrees, and it's not constant, but depends on the area of the triangle. The area of a triangle on a sphere radius 1 is related to the sum of its alpha, beta, and gamma angles by the Girard formula, which is equal to the sum of alpha, beta, and gamma minus pi, and is measured in radians. Spherical coordinates are a system of 3 numbers used to represent points in 3-dimensional space. In 3-dimensional space, the spherical coordinate system is used for finding the surface area. These coordinates specify 3 numbers: radial distance, polar angles, and azimuthal angle. These are also called spherical polar coordinates. Cartesian coordinates, x, y, z, are used to determine these coordinates. Let's find the surface area and volume. Cavalieri's principle states that if 2 solids are contained between 2 parallel planes, and if every plane parallel to these planes intersects both solids in cross-sections of equal area, then the volumes of the 2 solids are equal. To understand how Cavalieri's principle can be applied to find the volume of a sphere, we can compare the sphere with a known shape, such as a cylinder with a cone removed, creating a cylindrical shell. Consider a hemisphere of radius r. Consider a cylinder with height er and base radius r, from which a cone of height er and base radius r is removed. By using Cavalieri's principle, we establish that the volume of the hemisphere is equal to the volume of the cylindrical shell. The volume of the cylindrical shell, cylinder minus cone, is calculated as follows. The volume of a sphere is twice the volume of a hemisphere. Another way to find a volume of a sphere with radius er is to add volumes of a cylinder and a cone with height and radius er. The combined bodies are now compared with each other. To do this, we immerse them in a measuring cup. The water is displaced by the immersion, and the water level rises. The sphere is also immersed, and the water level rises by the same amount. This means that both volumes are the same. The surface area of the sphere is described as the number of square units needed to cover the surface of the sphere. The surface area of a sphere is the curved surface area of it, as there is no difference between the curved surface area and the total surface area of a sphere. This gives the formula. The area of the sphere is 4 times pi the radius squared. The area of a triangle on a sphere is equal to pi r square e divided by 180 degrees, where r is radius of the sphere and e is spherical excess. The amount by which of sum of 3 angles of a triangle on a sphere exceeds 180 degrees. The mathematical discipline that studies the relationship between angles and sides of spherical triangles is called spherical trigonometry. The angles A, B, C, and their opposing sides A, B, and C of the spherical triangle ABC are related by the following basic formulas. These formulas allow us to determine from any three elements of a spherical triangle the other three elements. Solve the triangle. Spherical geometry is used in navigation, so after substitution we can easily find that AC are 3117 nautical miles, which is 5772 kilometers. We can easily determine the distance flown by the Nightingale wintering in Kursk using latitudes and longitudes. If d is the distance between the two endpoints, L is d multiplied by r, where r is 6371 kilometers, the average radius of the globe. I hope you understood everything well and enjoyed watching this movie. Bye-bye. Irina Petrova.